All right. Back again.
All right.
So today we're going to talk about Dalton's law of partial pressure. I think this is personally one of the easiest, but
Yeah,
you know,
it's super easy.
it's simple addition and subtraction, and the subtraction is if it gets dicey.
Yeah.
Okay, so the Dalton's law of partial pressure, it just says that your total pressure is equal to the sum of all of your partial pressures. So we could do that in an equation where we say P with a subscript T, that's your total pressure, is equal to the P1 is your partial pressure of your first substance, the partial pressure of your second, the partial pressure of your third, and then it says dot, 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 dot.
6, 7,
So-
however many you have.
If it keeps on going, you keep the equation going. And it could be less than 3.
Yeah, it doesn't have to be 3. You could have just 2. That's fine.
Okay, so we've talked about everything. We can keep on.
So,
We have a first example.
yay! All right, so when it says, what is the atmospheric pressure if the partial pressure of nitrogen, oxygen, and argon are 604.5 millimeters of mercury, 162.8 millimeters of mercury, and 0.5 millimeters of mercury, respectively. Okay, so I'm going to add them up.
What did you say? I couldn't hear that.
I'm just going to add them up.
Oh, simple addition. I like it.
There we go. So there's my first
Hey,
pressure.
By the way, get out your calculator.
There's my second pressure. And there's my third pressure equals, plug them all in, 768.8, and our units were millimeters of mercury. Bam. That is my total pressure.
Told you it was easy.
That's it.
All right.
Pretty straightforward, guys. Okay? So, we're going to do some guided practice.
If you want to try it on your own, pause it.
You're guided. Okay, so what is the total pressure when you have a mixture of 5 atmospheres of oxygen, 3 atmospheres of hydrogen in a container?
Oh, wow. So there's just 2. I don't even think I need a calculator for this one. 5? 5 plus 3 is...
Are we going to
8!
count?
8! Yes!
8 atmospheres of pressure. Okay,
All right.
that's it. So, number 2. The partial pressure of helium is 13.5. If I can get everything to right. Okay, in a mixture of helium, oxygen, and methane gas. If the total pressure is 96.3, well, wait a minute, that's a little different.
Okay, so that's telling us the total pressure, so I guess we could come way over here and put an equal sign, maybe? Or is that...
Yep, because it's my total pressure is going to be 96.3. So all of them add up is going to equal that. So this is slightly different because it's giving me a finished product. So I also have an oxygen. So 29.3, but it doesn't give me my methane. So I have an unknown. Okay, you can put an X, you can put a P, methane pressure, whatever. Okay, so I need to figure out what's missing.
So since we have multiple numbers on our side with an unknown variable, we're going to condense so we don't have to move as many numbers around. We want to move as few as possible so we make as few as possible mistakes. So I'm going to do 13.5 plus 29.3, and my total is 42.8 plus X still is equal to our
96.3, so I need to subtract by this.
because I want to do the opposite of what I'm doing to X. So if I do 96.3 minus my 42.8, and my answer would be 53.5.
So I have 53.5 kPa for my thing.
Kilopascals.
And that's it.
That easy.
Not really any harder. You just have to think about it a little bit. A little bit.
All right. If you need help, ask.
Yay.
Until next time.